Now that we've got our TcpSocket listener set up, now it's time to code our actual TcpSocket. We already did a good chunk of this in pseudocode. Again, it wasn't perfect, but it was a decent base for you to see how things could actually be set up. But now we're going to actually set it up. So let's make a new class named TcpSocket. And we'll do the same thing we did for the TcpSocket listener by making it a public sealed class. And let's go ahead and include system.connect.sockets. And we need to know the amount of data that we can receive at once. So we're going to make this a public constant variable named buffer size. We'll just use the typical 8 kilobytes. And no, receiving more data at once is not necessarily a good thing, if anyone had that question. And then we'll have the size buffer length variable, so we know the size of the length of the data that we're going to receive, basically the header of it. And we're now going to make our actual buffer, our byte array that we're going to use to receive data. And let's make a private memory stream. And actually go up here and type and stop being lazy. Our payload stream. This is what we're going to use to store all of the incoming data. So if the amount of data we're receiving is, say, 10 kilobytes, we won't be able to receive it inside of one buffer cycle, one receive cycle, I should say. We're going to have to do 2 receive cycles, and this is going to hold all of the bytes that we receive. So if we receive 8 kilobytes in one, and then 2 kilobytes in one, 8 kilobytes will be written here, and then the 2 kilobytes will be written on top of it, and then we'll get the entire bunch out of this memory stream and then send it off into our event to be processed. So since these two involve data, let's put them together. And we'll make a object named sync. This is just for making sure that send can't be, or multiple threads can't use send at once. And I explained that in research videos. And of course, we need a variable for the socket itself, for the bare socket that we're using. And now we're going to need 2 different constructors. TcpSocket, which actually won't do that much. I mean, actually, yeah, we could instantiate the socket here. So this socket is new socket, first family.network, socket type .stream, and that wasn't the right one. Protocol type .tcp. And we're also going to need another constructor. And for this one, we're going to accept the socket as the parameter, and then we'll set our global socket to the reference of the parameter. Now, why do we have 2 constructors, you ask? And basically, so this constructor is going to be used if we want to, if we're on the client side and we want to connect to a server, and this is going to be if we're on the server side and we already accepted a connection, and then we're going to pass the bare socket into this class so we can wrap it up. That's what the 2 constructors are going to be used for. And now, since the TcpSocket can handle both connecting and wrapping a socket, we need to add a connect method. a couple of them. So we'll do public void connect, and then we'll just accept a string host and integer port. Still not quite sure why Microsoft decided to use an integer for these when a unsigned short can only go up to 65,535, which is the maximum number you can use for a port, but they decided to use an integer for some reason that just uses up 2 extra bytes, and I don't know, I'm not going to get into that, but let's just keep on cruising. We're just going to call the synchronous connect method. This is basically just calling the underlying stuff. Just go ahead and just follow along. There's really not much explanation here. This is just making sure we're covering all of the overloaded methods of the socket. I think that's it. There's an array of IP addresses, but we're not going to worry about that one. And we're also going to do the same thing for our asynchronous connect methods. Now, what we also could do is wrap this inside of an event as well. And actually, sure, let's go ahead and do that. Let's go back up to the top and let's do it in between here. Public event handler connection made. We could use 2 events, or we could do this in one. Let's do this one. Let's head over to our sockslib event args, and let's add a new class in here. Connection TcpSocket connection state event arguments. Public exception public bold connected. Let's make sure we make these properties. And then public TcpSocket connection state event args. I know that's a mouthful. Bold connected and exception. Let's call it EX. And then we'll set the exception of the class to the exception of the parameter. The same thing with connected. And now I'll break this thing down in just a moment. Follow along. As you can see, this should look similar to the TcpSocket listener. Okay, now that we have that straightened out, what we're going to have to do now is call the event based on what happens here. And we'll wrap this into a private void named on connect, which will accept connected and an exception. And we're going to do the same thing we did with the TcpSocket listener, and we're going to do connection state. If it's not null, then we're going to invoke the event, and we're going to pass connected, which will be from the parameter, and also the exception. Now, what are we doing with this, you say? We're going to make a exception variable here, which is going to be null, and we're going to do the same thing in these 3 methods. And then we're going to add a try and catch statement on top of this. Actually, no. I'm thinking of the asynchronous version of this. We don't need to do it for the synchronous version. Since an exception is already going to be thrown. All we have to do is set connect. We're going to set connected to true, which is a property we haven't made yet. Now let's go ahead and do that. And this is going to be outside the class, reused outside the class, and possibly inside, so we know if there is actually a connection or not. At least last time we checked if the socket was connected or not. This is going to be used later on. So now that we have these three set up, now let's do the asynchronous versions of it. Begin connect, string post, and import socket.begin connect, post, port, connect callback that we have not made yet, and set the state to null. Again, you've seen this before over here, but we're wrapping this up so it can be practical. So now let's make our connect callback, and this is where the odd thing I had you guys do earlier is going to come into play. So we're going to have our exception, which is going to be null, and then we're going to make a try catch. Let's name this connect. You can shorten this, connect EX for connect exception. Now we're going to call inConnect on the socket. And if the connection is successful, this won't throw an exception. If it's not, if it fails, then it'll throw an exception. So if it does fail, then we'll set the connect exception to the exception that was caught. Again, this is just so the application doesn't crash. And then in our finally block, we're going to call on connect, and we'll just pass connected along with the connect exception. And if any connect doesn't throw an exception, then this line of code or this block will continue. So we'll set connected to true. And then on connect is going to go ahead and call our event. We could have done it in here, but you'll see the method to my madness later on down the road. Okay, so now that we have our connect or our first asynchronous connect set up, let's go ahead and do this for the other two types. Again, there really isn't much explaining here, it's just wrapping up the overloaded methods. Oops, wrong method. Begin connect. Okay, so now that we've got this out of the way, before we continue, let's go ahead and test this out. You can follow along if you like, or if there's a screw up, then just wait for the screw up and then we'll go and fix the code. TcpSocket listener, let's call this L. no. And then we'll go ahead and shut the socket down. It's always good to test the tiny things before you put all the code together and then it all just blows up at once in case something went wrong. Then we're going to have our we'll make an instance of our TcpSocket, and then we'll just try the synchronous method first. Connect, which will be the loopback address on port 1000. And if something doesn't go wrong, then an exception will not be thrown. And something will go wrong because I didn't start the TCP listener. Okay? Because the machine refused the connection, because I didn't put the machine into a listening state. So let's start it up again. And the connection was accepted. Okay, so that works. And now let's try our asynchronous connection. We could have called it connect async instead. IP address.loopback. We'll go ahead and rename that later on. Console.line async connection state e.connected. If e.connected is not equal to true, we'll shortcut it with that. And we'll write the exception message. It should work, okay? You can see our listener accepted the connection and the connection state was true. Now let's not listen in and see what happens. Okay, connection state was false. No connection was made because the machine actively refused it, which is exactly what we wanted. And instead of this being begin connect, since we're not using in connect, let's call this connect async. And let's also rename this to connection result, or async connection result. Okay? Okay, that looks good. Okay, so now that we know that our connection methods work, let's actually wrap this up in a region. So it's out of our way. And so we don't have to scroll down through a bunch of stuff that we finished. Okay, and also one other method that I forgot. Now that we have the connection working, now we need to actually handle our I/O operations of sending and receiving. So let's name this initialize buffer. This.buffer equals new byte buffer size. And we'll call initialize buffer in both of the constructors. Okay. Don't worry about the payload stream for now. We're gonna handle this in a little bit. Right now, actually. So now that we have our connection methods, now we need to start reading data. Now the read is automatically going to be async. We're not going to do async receive. There's too much going on with that for it to be synchronous. Okay, so now under our connection methods, actually, let's just name this connection. Now we're going to make a private void named begin read. Again, something similar to what we've seen here, but making it practical. Socket, and we're going to call begin receive with our buffer. We'll just use buffer size. And I completely forgot the overloads for this. Socket flags 0 and read size callback and null. Now this is going to start to look really different from the example, and actually instead of buffer size, this is going to be the size buffer length. This is when things are going to get a little funky and way different from what we were doing in here. Since Microsoft, well, the server side was at least waiting for the end of the line, but the client side didn't. It just said that it received everything if at least 1 byte was received, which in a real-world application, things get split up. So we're going to make sure we can at least pack all the data together if it does get split up, which is what we're going to do with this right here. So now let me explain briefly what's going on here. We're going to use our buffer that we created to receive the size buffer length, which is going to be 4. In most cases, it should come, at least this should come at the same time, but there are cases where things get split. So like you get 2 bytes, and then 2 come maybe 500 milliseconds later, or you get 3 and 1's lagging behind, or you get 1 and then 3's lagging behind, and something like that. We want to make sure that that doesn't happen. So now let's go and make our read size callback, which is going to be the async result. Make sure we wrap everything in a try catch. But if you do wrap it in a try catch, just include system.diagnostics. Make sure you print the stack trace. It will save your life at some point in time. So we're going to do red is socket.end received with the async result. Now this is where we're going to check if the amount of data was actually received or not. The full, we're not sure if it's the actual size buffer, if it's a correct size buffer, because something could have got screwed up somewhere down the line. But if red is less than the size buffer length, then we're going to make sure we receive the rest of it. So at variable left is the size buffer length minus what was red, which would basically be 4 minus 2 or 4 minus 3, and then 1 would be what was remaining. That's what this is doing right here. And what we're going to do is just wait, since it shouldn't take that long, for the rest of the data to pop back up. So while socket.available is less than left, then what we can do is just have the thread sleep for about 100 milliseconds. And then once the amount available equals left, the amount of data that we still need to receive for the size buffer to be complete, then we're going to go ahead and just use synchronous receive to get the rest of it. we're still going to stick it into the buffer size, into red, and then we're going to use left. Socket flags are nothing. And that's it for this. Now let me explain what's happening here. We're writing it. We're going to use our buffer to write the rest of the data so we can get a complete, or think that we're getting a complete size buffer so we can know how much data we're receiving. And then we're writing it into the spot that's left in the buffer. So when in this instance we have 4 slots, since an integer is 4 bytes, if we receive 2 bytes, then the spot that it needs to start writing at would be 3, because 0 and 1 were already taken. Now it needs to write 2 and 3. So that's what we're doing here. If we receive 2 bytes, then it's going to start writing at 3. And since there are 2 bytes left, it's going to write 2 bytes into 3 and 4. So we complete our size buffer. Once that's complete, then we need to get the amount of data we need to receive. So let's actually head back up here and add another variable. Private int payload size. Now payload size is bit converter dot to int32. This dot buffer and 0. Now when we write our send command, our send method, we're going to use the bit converter to convert the 32-bit integer into a byte array, and we're going to use the same bit converter to convert it from a byte array back to an integer. Since we wrote the bytes to the first 4 bytes of this buffer, and our index is set to 0, that means it's going to start from the beginning and it's going to read the first 4 bytes in order to get the payload size. And after we get the payload size, now we can create the memory stream. We're just going to hold the full payload, and then we'll start the payload receiving process. So socket begin receive this dot buffer. We're going to start from 0. It doesn't matter what the positioning doesn't matter now. And then we'll use the buffer size and 0, and then the receive payload callback. And there's also no point in going back to the Microsoft example since we're venturing off the fork in the road now. And also there's one other thing that we need to look at here. Since we're receiving with the full buffer size that I put here by mistake, I'm just going to show you guys, or explain to you where this could go wrong. If we're receiving 8 kilobytes exactly, then this will work just fine. But if we're only receiving, say, 20 bytes, but we're sending data rapidly, and there's a delay, some data gets chunked together, and then everything comes at one time. If we receive 8 kilobytes as a whole, every single time, then we're receiving the 20 bytes along with some other stuff that piggybacked along with it. So what we need to do here is check the payload size before we set what needs to be received. So let's actually name this initial size. This will be a variable that we're about to create. Let's do this under payload size. Int. I'm going to use bar just because. Initial size equals this payload size is greater than the buffer size. If it's greater than the buffer size, then we can go ahead and use the buffer size to receive, since nothing is going to hurt it. If not, then we need to use the payload size and only receive what was actually sent, or the tiny amount of data that was sent, which would have issues like what I explained earlier. If we sent 20 bytes, but we also sent 100 bytes right after that, 120 bytes could come at the same time, and if we receive with a full buffer size, everything will be clumped together. So it's good to only receive what we need to receive, process that, and then only deal with what we need to deal with at a time. And with that blabbering out the way, let's make another callback method. Receive payload callback. Basically the same thing. Error try and catch. Make sure we print the stack trace somewhere. And now here we're going to do something similar we did with the size callback. We will call receive on our socket. We're going to call and we're going to take our red variable and we're going to negate our payload size. So payload size minus equals the amount of data that we read. And then we're going to write to our payload stream the buffer, 0, and the amount of data that we actually read. Now if payload size is greater than 0, meaning there's still some data that we need to receive, then we need to check if the payload size is greater than the buffer size, similar to what we did last time. So int receive size equals, there I go, not following my own pattern again. Okay, if this dot payload size is greater than the buffer size, then we're going to go ahead and use the buffer size. If not, it means there's not that much data left in this payload, so we're going to go ahead and receive with that size. And then we'll call begin receive this dot buffer 0, the receive size, oops, you don't need any socket flags, the receive payload callback, and we don't need an async state. Now, if we did receive all of the data and the payload size has hit 0, now we need our actual event for this. So let's go into our socketlib event args, and under the TcpSocket event state, we should call it the async state. We'll change that later on. Public class TcpSocket received event args. Make it inherit the event args class. Then we have public byte payload get private set. In public TcpSocket received event args byte payload. This dot payload equals payload. Now let's head up top and add another event in, public event handler TcpSocket receive event args. Let's call this data received. Now let's head back down into our payload callback, and what the heck, I forgot what I named the event already. Data received. If it's not null, we're going to invoke it. Sender is this, and the received event args is going to be. So let's put this in a variable. Payload equals payload stream dot to array, and we also need to close the payload stream as well. Set the payload stream to false, so the garbage collector can nom it up, and then we'll pass our payload bytes into the event args. And also, like I mentioned, in the TcpSocket listener, make sure you call begin read before calling the event. Because I know most of the time, you're gonna, unless you spin off another thread, you're going to be handling your receiving inside of the event. And if we call begin receive after this, I don't know how much time it would take for you to process all your data before it can start reading again. But if you make sure you call read first, then you can take all the time in the world on the thread that it uses. Well, I wouldn't use all the time in the world per se. If it's just a figure of speech, don't take that quite literally. But you get what I mean. You can take a little extra time because the receive process already began again. So now that we've written all of this code here, let's go through and analyze exactly what we did. First, in begin read, this is the start of the reading cycle. We call begin receive, which is typical. You've seen this. It's going to receive into the buffer. We start at 0. This is where things start getting a little different. We're receiving only the first 4 bytes, so we know the size of the actual payload that we're receiving. And we will be using two callbacks. The first callback is the read size callback. We should call it receive, but receive, read. It's kind of hand in hand. If you've used the network streams, you would understand why I'm getting my words crisscrossed. But don't worry about that. As long as everything functions correctly, you can always change that later on. But now in our read size callback, we are calling in receive to see how much data we actually did receive. If the read length is smaller than the actual size buffer length, that means something got split up along the way, and we want to wait. Actually, we're getting the amount of data that's left that we need to receive, and then we're going to wait until the socket actually has that available. Once it's available, then the while statement is going to break. We have this here just so it doesn't kill the CPU by going in an infinite loop. And then if there is data that we haven't received, then we're going to go ahead and receive the amount of data that's left. And there's an actual problem here that I missed. Copy all of the code underneath the receive method and move it outside of this if statement right here. This is in place right in the middle of this, just in case something goes wrong receiving the size buffer, just in case there's a delay. This code shouldn't be in this if statement, because the only way it would actually receive data is if something did mess up. But continuing on down the line, we're getting the payload size from the first 4 bytes that we received up here. We're getting the initial size, checking if the payload size is greater than the buffer size. If it is, then we can go ahead and receive with the full buffer size, because we won't worry about reading more data than we actually wanted to read. But if it's less than the buffer size, then we can go ahead and receive the rest of the data that's left, because it's not going to actually hurt anything. We won't receive more than we actually bargained for. Then we created the memory stream to hold all of the data that we're receiving in the chunks. And then we started receiving using the initial size that we got up here, but instead of going to receive the read size callback, we did the receive payload callback instead. Now this is a whole nother loop on its own. Same thing we did in the receive callback, in the read size callback. We called in receive, except this time we negated, subtracted, whatever word you want to use, the amount of data that we read from the payload size. And then we wrote from the buffer, from the data that we just received, using the length that we just read. So we're not writing more and we're not writing less. And if the payload size is still greater than 0, that means we still have data that we need to receive. And we did the same type of check that we did in the read size callback. We checked if the payload size is greater than the buffer size. If it is, go ahead and use the whole size because it's not going to hurt anything. If we receive less or we receive more, it'll be just fine. If not, then try and receive the rest of the data. And then we started the loop, like the entire loop again with the receive callback. But if the size did hit 0, meaning we did receive all the data, first we have to close the payload stream so we can access the actual data. Then we got the actual byte array of the entire stream, and we stuck it into a variable. And then we set the current payload stream to null so the garbage collector can nom it up, since we got rid of all the references to it. And then we started receiving the data again from the beginning, and we called the event with the current data that we just received. So the event method can use this current thread to process its stuff without interfering with the actual receiving of the data. And now that we've got all of that laid out, let's see. What do you mean the buffer is never used? IntelliSense. Used right there, and the buffer is used right there. I don't know why it's saying that. But now let's go ahead and test this thing out. So for this test, it would be better, instead of doing this all in one, it's still going to be in the same application, but it's going to take 2 different paths. So let me show you what I mean by that. We're going to make a static void client, and then we'll make a static void server. Now up here, what we're going to do, so we're still going to have read line. We're going to press return to continue, even though we already know that. Type, variable type equals console.readLine. We're going to take input and see which one we're actually going to use. So let's do write, select type, we'll have S for server, and then we'll have C for client. Then we'll select the type, which will be readline dot to lowercase, just in case we use uppercase so things don't get all screwy. Switch type, case C, break, and case S, break. C we'll call the client method, and then S we'll call the server method. And let's do the client method first. So I have the TcpSocket, and then we'll attempt. I'm not going to worry about exception handling. We need to check the actual receiving part of it. The loopback address, and then we'll just use port 1000. and we'll use a loop of we'll use a loop of 10 to start. And then this will handle data receiving. Actually, we're not using anything synchronous right now. So we're going to have data received. We're going to have console.writeLine, amount received, e.payload.length. And then we'll just call leave line here. Actually, we're not going to need that. That's what this is for. And now on the server side, TcpSocket listener. It's better to test the small components as you go along. So if something does screw up, we can go ahead and catch it together. And it's better than building an entire application and then everything is all wonky. Start TcpSocket client. I'm going to use the socket using the socket that we accepted. Even though we're going to change that around and make the socket into a TCP socket, so we don't have to do this instance creation right here, but we'll do that after we make sure everything is running just fine. And one thing that I realized that we didn't code yet is the actual send method. This is not going to work without the send method. But let's go ahead and set this test up first. I less than 10, and then I plus plus. We'll come back here and finish this off after we add our send method in. Again, let's put this in a region, just so it's out the way. Now let's do our send methods. A public void send byte payload. Now this is going to use begin and end send. So we use this socket dot begin send. Pretty simple. We're not doing anything loopy or special here. 0 payload.length. I just realized it's length twice for some reason. Socket flags 0. Async callback. We really don't need a callback, but we'll go ahead and do that anyway. Send callback and state is null. Private void send callback async result. AR again. Try catch. Make sure you print your stack trace. I'm going to embed this in all of your brains. End send. Okay, and that's all we need to do for this. Okay, and we're also going to make, oops, actually, I screwed up. There is something extra we're going to have to do with this. I forgot what I even wrote. Let's go look at the pseudocode here. And now, what did I miss here? We need to add the size buffer into the payload. So what we're going to do here is we'll just use the second method that we did in the pseudocode. So we'll have the size buffer equals bit converter.getBytes. payload.length byte full buffer equals new byte size buffer.length plus payload